If I have an A that's somewhere between 0 and 1, I keep multiplying this A many times, it converts to 0. So you can think of it as half, and then 1/4, and then 1/8, and then 1/16, and then in the end equal to 0, right? How do I prove that? First, I write down this. What's this? Let's recap, do it slowly. I have my AN, this means A power n. What's my L? It's 0, so it's 0. Epsilon is there, okay, this. And then 0, I can remove it, and this guy is always larger than 0 because by definition, so I don't need absolute value. So I have this, then what? I need to find big N, so I'm going to find small n first. I now take net total up, okay? And then I have this to this. Basically, I just divide this guy to the other side, but since A is more than 1, so negative. So that means you flip the inequality. Now this answers the question, how do I find big N? This is true, then this is true. So I need an integer. Then I just say, oh, I take the nearest integer, the next integer, done. Here's another one. How do you prove this sequence go to 0? That means, and in the end, it will be, let's say, 4,000, and then 4 trillion. It will be very small, in the end, it's 0. How do you prove that? Same thing. Write this down. This, my AN is just 1/n, okay. My L is just 0, okay. This guy just copy. Simplify the mathematics, I get this. And I have this, write everything as n. So n is larger than this. This is not an integer. Make this so I have an integer. Done. So for any n larger than this number, all the sequence after this cutting point, I beat your disagreement. So basically, all the limit is just this sentence. You disagree with my claim? Okay. For all disagreement, red part, I resolve your disagreement by saying that your disagreement is saying that there's a gap, then I say no, it's within your gap, then fine. That's it. An important point is because you say there's a gap, you are disagreeing with me. So this epsilon is larger than 0. Later on, what's the definition of differentiation? You see this thing again, but this part changed. What is the definition of function is continuous? You see this thing again, but this black part changed. What's the definition of an integral? You see this thing again, but this black part changed. Everything you see in calculus basically is just after the red thing, I do something different on the black thing. That's the whole picture of calculus. The idea is, yeah, we now go to something in infinity. But as long as I can count out all your disagreement, then what I claim is true. This is the reason why we need this. In the old days, when Newton invented calculus, of course, he don't have this in mind. He just said that, okay, calculus, differentiation, it's just like a slope getting very small, very small, very small. So now you see, slope getting very small, very small, very small is a limit. So later on, in differentiation, we do this again on slope. But then in that time, Newton don't have this idea. So he just writes some expression and then say that, oh, these two terms can cancel out. It turns out this is wrong. Sometimes you cannot do that. We will touch an example on this later. Then people are scared. And then few person, one from Germany, one from France, fix this by saying you need this. If you have this, no more danger. This is why we study this. All the calculus you learn in high school is basically in the Newton's era. Basically, okay, this is true, this is true, this is true, but now I'm saying why is. Then now let's continue. Now I have a bunch of English sentence. What matters is the picture. Let's say this is a sequence. Blue is the sequence. The first picture is saying that I have one upper bound, the smallest upper bound, and this I have one lower bound. This picture is saying that I can have more than one upper bound. That means I'm not saying the upper bound is unique. I can have any line above my blue dots. So this is called bounded. You have two lines bounding the sequence. Strictly monotonically decreasing. So monotone means you only go one way, you don't turn back. So this is one way. And which way? Decreasing. This one is funny. This one is also decreasing. You say, no, it's not moving. Okay, this guy also have equal, right? So therefore, it's also decreasing because this means either smaller than or equal is true. This one means you don't have equal. Okay, so this is the meaning. So these are the English sentence of this. Then now here's an example. Is this sequence bounded? Yes, and the bound is 1. You think about it. The smallest n is 1. So the biggest number you can get is 1. So the bound is 1. If n is bigger than 1, it's only getting smaller. So yeah, is this monotone? Yes, going down. Actually, this one is this picture. Okay, is this convergent? Yeah. What about this one? -1n. Is it bounded? Yeah, it's bounded by 1. Okay, let me recap. When we talk about size, we always take absolute value. We don't care about the direction. So we take absolute value. So the -1, the negative sign gone, is bounded between 1. But is it monotonic? No, because it go up, down, up, down, up, down, up, down. So it's not single direction. So no. Is it convergent? No, this series diverge. What about n? That means 1, 2, 3, 4, 5. Well, is it bounded? No, because you can go infinity. Is it monotone? Yeah, it's monotone. It keeps getting bigger. Is it convergent? No, because it have no bound. What about this? Same. Okay, so these are examples. You don't need to read the proof. I'm not going to test you the proof, but you need to understand the idea. If I have a convergent sequence, it's always bounded. Let's say this 0.9999 is bounded. Bounded by what? 1. The limit is the bound. Okay? This guy converts to 0. Bounded by what? Upper bound by 1, lower bound by 0. This guy also bounded. Lower bound by -1, upper bound by 1, but it never converges. So it's saying that if you have a convergent sequence, the picture looks like this. It's always bounded. That means you can always find a bar on a top and a bar on the bottom. And in other words, we kept mental hospital. These have infinitely many number, infinitely uncountably infinite many number. I'm saying infinite number of stuff always within this box. Okay, this is bounded. Okay, so this is the meaning. So the mathematics is if a sequence converges to L, that means the limit is L. I can always find an M such that this is true. But the opposite is no. A bounded sequence does not imply conversion. For example, the negative one, this one, is bounded by 1 and negative 1, but it oscillates, so not converge. This kind of A implies B and B not imply A is very, very tricky, so be careful. And then bounded and monotone give you conversion. So now we have three things. Conversion give you bounded. Bounded don't give you conversion. Bounded and monotone give you conversion. This implies this. Bound do not imply conversion. I don't draw an arrow. Bound and monotone imply conversion. So B and M, we can say is an N. Then give you this. Also, is conversion monotone? Not necessary. Later you will see an example. Okay? Bounded and monotone conversion requires something from topology which you don't know what the heck I'm talking about. So no. So I'm saying this kind of stuff, sometimes you think it's common sense. No, it's not common sense. In the end, you need some crazy thing to prove some common sense.